So leading into this next talk, what I'd like to say is we have pretty fundamental changes happening all over the world of IT, right? We have DevOps, we have DevSecOps, we have cloud transitions and digital transformation and all sorts of stuff like that. That is leading people to leverage everything in a something as code if possible, right? And the reasons for that are obvious, right? There's a lot of complexity going on. It helps manage that. It helps us version control that complexity. It helps us scale things. And security is no different, right? Security is scaling and dealing with all of these problems as well as we try to take in logs and data for all of that stuff and contend with all of these new different attack types and attacker tools that we were trying to figure out, can we catch them? Can we not catch them? And all of that sort of thing, which leads to what some have called the GitHubification of InfoSec and things like Sigma and all that awesome stuff that we can use and share across, everyone as a blue team. And the more that we can share, the better we're going to be at doing this sort of thing. So this next talk, really excited to hear about. We're going to be talking and hearing about how you can use blue team concepts and implement those as code from Oleg Kolesnikov and Dan Uzvik. So without further ado, I'll pass it over to them. Blue Team as Code, lessons from real world red team detection automation using logs. Over to you folks. Thank you.
Can you guys see me?
Yes, you look great, Oleg.
All right, thank you. My first time here. So, all right. So a couple of words about my background. I've been running threat research and development labs, blue and red teams, SOC and detection engineering work for many years. And one of my focus areas is on real world cyber attacks and how to defend against them. I also have Dan with me. So he's one of the senior threat researchers for Securonics. His background is in threat research and detection as well. And he'll be helping with some parts of our presentation today. So today you'll learn about blue team, as John mentioned, blue team as code and how you can automate red team detection with the ultimate goal of better detecting the real world cyber attacks. I mean, this is ultimately what it's all about. To set the expectations for you guys, we have not reached the blue team singularity yet. There's still some human analyst involvement required, maybe one day. Also, we're not the first ones to think about some of the concepts and tools that we're going to be using code for detection in particular, Jupyter notebooks, etc. So I wanted to give some credit to all of those researchers, to name a few. Great work from Roberto Rodriguez on threat hunting playbooks, the ideas from Anton Chivakin on detection as code, Augusto Barras on detection lifecycle, of course, Florian Roth and the Sigma community that John mentioned, great use cases for red team detection. So thank you to all of those researchers in the community. We're standing on the shoulders of giants here, but what we want to do today is to bring some of these great ideas and theory, and there's a lot of theory when it comes to detection as code, one step closer to reality. So here's our agenda for today. So first, we'll talk about blue team as code fundamentals, tooling, etc. Second, we'll talk about some of the latest red team tradecraft relevant to code automation, as well as blue team blind spots. Next, you'll see a real world red team detection demo using code and some practical examples. And we'll then conclude with some key takeaways. This is going to be a vendor neutral talk, no product pitches. And we'll also share some code and examples with you on GitHub. And also, this is going to be a fairly technical talk. I still do quite a lot of technical work on a day-to-day basis as well as Dan. And it's going to be fairly dense. So we'll be going relatively quickly. So if you miss something, you can go through review or reach out to us afterwards. So now, let me start by sharing a personal story and how this idea of blue team as code came about. So many of you here, probably because you either lead or work as part of blue teams. But instead of a blue team for one company, imagine having hundreds of very large companies, many with hundreds of thousands of users, with logs sent to the cloud. And each company may run their own red and blue team exercises, getting attacked, etc. So all of the telemetry comes to the Securonics cloud. And if you think about blue team in this case, it's almost like a meta blue team. So you get all this visibility, and you get to learn much faster in this scenario about some of the latest red teams and their tricks and trends. And so we're going to be sharing some of those with you. But one of the key highlights for the modern red teams that we're seeing in the wild is they're increasingly exploiting the blue team alert fatigue, hiding within benign, hitting the blue team's pain points. So red teams get evasions and latest functionality out of the box, essentially, with all these tools. But we as blue teams, we as blue teams, we have to spend hundreds of man hours to cover each attack tool release for detection. So it's effectively what we call AOD, automate or die nowadays for blue teams. And that's where that's where the automation comes. And I think it's time for us to level the playing field a bit more and give blue teams the tools to automate and be more effective at detecting red teams and ultimately the real world attacks. So now I wanted to talk to you about the fundamentals a little bit. So for blue team as code automation, it is important to factor in what we call the bathymetry or depth map of your environment and MITRE ATT&CK techniques, right? Because it's not flat. And there are these areas, if you think about MITRE ATT&CK techniques, you can think about different types of techniques, different levels of detail required to cover them. And what red teams are doing is that they like to hide in these deeper places, right? And it's not, these parts are deep in this, not only in the sense that there's more required from the blue team to cover them, but also in terms of your environment. For instance, some attack techniques are relatively shallow, right? You could easily detect, you could easily take some of the sigma rules and cover them in your environment, right? But some are fairly deep, and also you have your normal DevOps activity that is on top of it. So, for example, if your DevOps or admins are using WMI and your red team chooses to use offensive WMI, right? You have a problem right there. You need to be able to somehow automate and take care of it. So this is where blue team as code comes in. Now, the other key element to this puzzle that we have here is the detection spectrum, right? So you can think about it as deep water phishing and shallow water phishing, right? You have the more specific use cases on the left, and the more sensitive use cases here. So a lot of the results for blue team to pivot for these, right? These have higher false positives, but you can also catch a lot of the red team activity with these more sensitive use cases. On the other hand, we have the more specific ones, 0 to few results often, but very easy to evade. And one example would be this trivial sigma, right? You see these details here. Essentially, what we're looking for is the execution without arguments. So this is a good bad OPSEC use case, but of course it's very easy to evade, and it's somewhere to the left of this detection spectrum here. And red teams have all sorts of tooling to evade these sorts of detection use cases. Argue, command, and CS beacon, and many others. Right, but you can make it more specific, of course. You can baseline what's going on. I'm going to touch on that in just a moment. So the other example would be another simple example is a bit more deep, and this one is PSExec except ULA use case. So this one looks for PSExec and the other string, the except ULA. But what's interesting about it is that if you use this one in an environment that doesn't have PSExec used as part of business as usual, BAU, it can be quite useful, except that nowadays it's much more along the lines of C#, WMI. You can replace it with PS remoting or whatever. But it is generally more sensitive, right? So it allows you to catch more things. But of course, the catch is, how do you de-rabbit hole? How do you deconflict this with your admin activity, right? And so with this, what we realized is you have to combine specific and sensitive detection use cases to detect red teams, right? But how can you filter the results produced by these more sensitive use cases to catch red teams? So that's where the code comes in. And the answer also is that you can use Omega for this. And I'm going to explain what Omega is in just a moment. But let's just take a couple of minutes to discuss that. So Omega is an open source framework we came up with. It's backward compatible with Sigma. And we spoke with Florian Roth earlier, who's a good friend. He provided some great feedback on it. But what Sigma, what Omega is, it adds code to Sigma essentially on top of Sigma, right? That's one of the things that it does. The other thing is it allows you to chain multiple Sigmas together, right, for BlueTeam purposes. And then of course, you can add some behavior-based features to it, and then you get the Omega. So basically, at a high level, should be pretty clear. But now let's talk a little bit about the details, right? So and adoption as well. So we have some early adopters of Omega already, but essentially what it looks like under the hood, right? And let me just start this quick video for you. So you can see that it very much looks like Sigma. You have this top portion with the detection part, You have also the code-based portion here in the lower part. And most importantly, you can see here that what you can do with it is that you can reuse code across different use cases, which we find is very important. For example, if you want to detect something and visualize a logon session across the results, right? You can reuse code, almost like we're borrowing some of the concepts from the software engineering, right? So the other highlight I have for you is if we go back to the bathymetry, now that we know about some of these key concepts, right? If you look at these deeper areas and the shallower areas, I mean, we as blue teams, we can still use Sigma for the shallow detections, right? But for the deeper ones, we could start using Omega and add code to the mix, so we can obtain much more filtered or much more much better signal out of it. But most importantly, what Omega allows you to do is you can generate new detections from code. So your code can generate more specific detections. And secondly, you can take the code and you can refine your existing sigmas and omegas to reduce false positives. And we're going to have a demo on this for you in just a moment. So moving on. Now let's talk a little bit about the tradecraft, right? What we've seen from red teams, and I'm not going to go into too much detail, but some of the key highlights for you guys. Red teams nowadays is much more OPSEC aware, right? We're seeing them hiding in benign known good a lot. There's a CS beacon buffs. You have all the end-key payloads, etc. Then we also see red teams exploit blue team visibility and blind spots very actively. So they would do what we call the in vitro probing, where they develop payloads in their environments, right, off of the target environment. And then when they run it, it's not detected in your by your tools because they already tested it, right? We also see much more eradication resistance, because we also want to talk about eradication. I know Justin and Ismail were talking about the fact that whether or not we can trust the endpoint, right? And so we're going to have I think a good example on that. But ultimately, red teams are well aware of what we're going to be doing as blue teams, right? It used to be a couple of years ago that you could just run a simple get injected thread, look for RWX segments and some of the unhooked set thread address parts, and bam, you can kill the threads and kill a lot of the hooked processes. Not anymore, right? They have all of these cool tools, sleep mask, artifact kit, and Florian and I were joking about this earlier, where basically with each release, all they have to do is upgrade from CS Cobalt Strike 4.1 to 4.4, and now we as blue teams, we have to spend hours and hours to cover all those additional evasion techniques. And then lastly, right, and this trend is very worrying to me, right? The fact that there's much more automation on the red team front as well, right? There's aggressor CNAs, there's community automation, so all of that is we're up against all of that, so we need to come up with an answer. And on top of it, right, we have the common blue team blind spots, which is one of them we still see a lot, believe it or not, right? Is having the required telemetry. So we would get some CISOs reaching out and saying, hey, we have this basic AV proxy firewall logs, and we have a red team exercise next week, and how can we automate and use code to detect it more effectively? And the answer is, you know what? You need to take care of the basics first. Get the required telemetry. Without it, your return on automation investment or ROAI is going to be very limited. Sorry. The other highlight I have for you is also the fact that many blue teams are not able to leverage these sensitive use cases that we talked about effectively, right? They lack tools to be able to act on them, to visualize baseline, pivot chain, etc. So the thing as red team is good, that Ismail was talking about, right? Now we have to act on the blue team side. So that part is missing. And hopefully blue team as code can help you guys be more effective there. And of course, some of the other highlights, do not expect modern red teams to write payloads to disk, do not expect them to spawn into run DLLs, service hosts, right? They don't do that anymore. At least we don't see that much, right? Even for grab beacon configs, the trivial grabs that you're doing on their infrastructure, right? Expect them to be aware of it and shut it down, right? Now, do expect them to run payloads via your whitelisted apps, DLL side loading. Do expect them to evade your AV and EDR solutions, right? Using memory payloads, etc. Dan, over to you.
Thank you. There are multiple areas where detection as a code approach could help us a lot. I will provide a few quick examples. With auditing your logs with code, you can quickly find and understand gaps. For example, you can audit what log sources and what events ID are missing. By visualizing with code, your results that you get from hunts or investigation, you can bring additional story around this and provide some context to better understand what is going on. Apply clustering, and you get some outliers from process creation events, command lines, network. Start working with this as a starting point for hunting, for example. Code-driven baselining is the most effective way to find common patterns and filter benign behavior. Code-based eradication allows you to take immediate action during hunting or investigation, from getting a hash value from remote workstation to remove it across the environment. And I want to highlight that as a BlueTeam, we are able to scrutinize known good processes and use this as our advantage to detect red teams that are trying to blend with it.
Thank you, Dan. All right, so guys, one more thing we wanted to cover before we jump into our demos, and there's going to be a lot of them. So most of you know about this, the pyramid of pain, which is cool concept David introduced many years ago. I was actually at the talk where he did this in Cambridge. But it's a great concept. It's a great theory, right? But it doesn't say much about the acting part. What are we as BlueTeams are going to do about it? Because I'll explain. You can think about it. The bottom part, which is quite clear. You're gonna look for the hashes, the values. But the truth is, it doesn't work anymore. I mean, with the red teams, they're aware of it. They're changing their artifacts, right? And so it's all about the TTPs nowadays. But that is the hard part, right? How do you detect TTPs, right? Given that you often need sensitive use cases for this. So we came up with this concept of BlueTeam as code spiral of joy. Instead of the pyramid of pain, we came up with the spiral of joy. And here's how it works. So phase one, you start with a sensitive use case, right? Phase two, you use code-driven visualization, contextualization, pivoting, dynamic code-driven clustering, etc. Right? Phase three, and it's very important, your code can be used to generate more specific detections. You can use detection variations as well, right? Based on knowledge base. And then you also tune your sensitive omegas for false positives. Then phase four, what you can do is you can apply those artifacts that were generated from code and from your investigations using code at scale across the organization, right? You apply them, you can apply them via autonomous threat hunting or some other method, right? And then phase five, is the joy phase, right? You hopefully are able to detect red teams much more effectively, and most importantly, eradicate them from code. And we're going to show this example as well. So we're going to show some of these in action today. And you have a much larger base of detections that are much more current to red teams. So all of this looks good in theory. Let's jump into some practical examples, because I mean, that's what matters. All right, so the first example is going to be the real-world red team detection using code. This is actually from one of the actual customers that running a red team exercise. We had to rebuild this in our lab to minimize, any possible privacy issues. But essentially, all the key parts are there. So to set the stage, it was a fairly long chain of behaviors from the red team, right? There was a bunch of things happening, and then eventually they used the persistence payload drop into the scheduled task folder, which was executable, right? Then they used a PowerShell stager from private GitHub repo with some encoded PowerShell. We see that quite a bit as well. There was a custom power up variant with some lateral movements, with some encoded payloads for OPSEC. And on the BlueTeam side, what we did was we had this fairly sensitive use case where we looked for scheduled task folder drops, and also it was actually much a bit broader. We also look at unusual executables from CTEM folder, some of the app data folders, and then the analyst pivoted on that to visualize the logon session, and through the code reuse and code assisted detection, we were able to detect some suspicious artifacts and then extract them and apply them across other systems, and then eventually detect the customized Power App with the private GitHub repo or SYN. So I'm going to show you in just a moment. So here is what it looked like. All right, so basically what we're doing first is, we're setting up our initial detection, which is going to be fairly broad. It looks for all the drops into scheduled tasks. And you see this converted query, because we operate on next-gen SIM in the cloud, we query the SIM. So what the analyst did was they found this drop, the UPnP.exe, which they wanted to investigate among many, right? And you see this session, the session ID here. So the next step was to visualize the session and also extract some of the details on the fly from the events. Remember, because we operate on the logs here. So you're going to see, as you're going to see in just a moment, what we're doing is we're building this nice visualization, from code, and you can, it's very, very flexible. You can do a lot of, you have a lot of flexibility, obviously. So you have all these different sessions on the target, and one of them looks suspicious. You see the UPnP and you see PowerShell. So the analyst wanted to, delve a bit deeper into this one using code. And so the next step they did was they extract that particular PowerShell event, and they did some decoding on it, again, using code. And this turned out to be a get modifiable registry auto-run module from customized PowerShell. So the next step they did was basically they extracted part of this nice blob, the first part, which is a $, encoded, and they applied it across the organization right away, right? Looking for different artifacts and how they, how basically the blast radius of this attack, right? And so after that, what they've done is they correlated that with other payloads, and you can see here some of the other payloads with the redacted private GitHub repo with some custom power view and other payloads that the red team members were downloading to other systems, right? So with little OSINT challenge, the analyst was then able to identify the person behind this. It was a actual senior advisor at a major firm, and so that kind of wraps up the demo. All right, so with the next one, this one is on attack chaining and de-rabbit holing, where we look at chains of techniques. And I think in the interest of time, Dan, I think we're going to skip this one. I'm just going to mention a couple of things, and if you guys are interested, I can share this example afterwards. We can walk you through. But some helpful links here. There's great work from MITRE on chaining. And we strongly recommend that you use this to determine which use cases you can chain. And again, we have a demo on this, but we're going to skip this this time. So the next one, Dan, did you want to take it over?
Yeah, thanks. BlueTeam as code is a good way. BlueTeam as code approach is a good way to fill gaps in log sources. Let's quickly review Golden Summer attack. It's attack technique that allows attackers to bypass IDFS authentication. It's possible to detect forged SAM responses by correlating cloud sign-in logs with on-premise authentication logs from IDFS and domain controller. But unfortunately, by default, some kinds of logs are not collected. So with code, we can quickly load raw logs into Jupyter and transform it to pandas data frame and build correlation around this.
All right, moving on.
Next example is related to phishing with cloud apps. Red team's objective is to get access to access token of target, to get access to O365 environment by luring the target to authorize third-party application. With this token, Red team could get access, for example, to email on behalf of targeted user without the need for credentials and bypassing any two-factor authentication that may be in place. In this case, BlueTeam detection will be triggered by simple event, something like new application registered, without any additional context like what permissions were granted, what application name. And the code could help us fill this gap We can run this code separately to get these details, or by enriching this alert in background.
All right, so we have another Nano demo here for you. Let's just get started.
We're loading Omega. Omega will build for us all Jupyter lab cells and will guide us to investigate how to investigate this kind of alerts. We connect to tenant and we will review all delegated and application permissions granted. After review, we may notice the application that was delivered through phishing with pretty dangerous permissions like mail.read.
All right, so I wanted to add one more thing to this, and thank you, Dan. It goes to what Ismail and Justin were saying earlier about the fact that we shouldn't necessarily trust your endpoint data, right? So this is a good example of where code could actually be used to dynamically pull in some truth mark data, some additional data sources to validate whether or not you might have, maybe a rootkit on your system. Of course, in this example, we're using the cloud data sources to augment the visibility of the BlueTeam analyst, but there can be other data sources that you can use in your environments to really empower your analyst, your BlueTeam analyst, to be much more productive. So moving on, and I think we have, okay, all right. So this one is going to be an example of the eradication from code, which is also very important, Dan.
Thank you. In this pass the cookie example, the team's objective is to dump cookies, target cookies with these cookies, and get access to cloud environment and GitHub account. One way to extract cookies is to launch Chromium browser in remote debugging mode and send API requests to get all unencrypted cookies. Red BlueTeam objective is to detect cookie dump attempts, find beacons, and remove malicious payload.
All right. So a demo here. Let me start this one.
We load necessary libraries, initializing client to sim with SOAR capabilities, then converting Omega to query, and then we will run it in a given time frame. When we receive results, we start analyzing it, and we see that this is true positive, and we are interested in parent process. We get information about parent process, and now we will take command line, and we will show for a moment a demo VM to make sure that this process is up and running on this demo VM, and we will extract workstation name and hash value of this suspicious payload. Later, we will use SOAR microservice to query this hash in VirusTotal, and then we decided to terminate this process and remove it from remote workstation.
Thank you, Dan. And just a quick highlight, VirusTotal is just a trivial example. Of course, red teams are much more OPSEC aware nowadays, so don't expect those payloads to be on VirusTotal. Same thing with the, with the real world threat actors. Now, moving on to our last example here, what I really wanted to show you is a first example of the code generated or evolved detection. This one involves a run DLL Sandbox bypass, where they run a run DLL against their DLL payload against a custom function there, which can produce some noise for the blue teams. So here's how it works. So let me just fire the demo. Okay, so first the analyst takes the the trivial check. You can see the run DLL with DLL register server parameter, which can produce a lot of noise, right? There's typically we see a lot of activity for this in the environments. And the next step is to load the Omega, the detection and the code embedded, and then start the running the code. You can see the blob with the code, and then it gets decrypted and put into the cells. You see the connection to the cloud SIM there. with the mappings being loaded and some of the queries extracted by the code and then run against the target. But what's interesting here is these are the results, and you can see a lot of the false positives here. The FCAGs are the false positive, but the one on the top, analyst knows that this one is a true positive. And so what they want to do is they want to quickly turn that into detection, right? So the first step in this would be to isolate this particular violation or the event. You can see it here, and then they pass this to a function, which is going to take that the data and turn that into a newly born omega or new sigma. And let's take a look at what it looks like. And this detection was created completely hands-free, right? So this is all code driven, right? It's not perfect, but you can evolve this significantly, and then you can take this detection and you can apply this to your other systems. You can do all sorts of things with it, convert into things, and then take action on it. So hopefully this shows you the end-to-end life cycle, the spiral of joy that we shared earlier, and how it works in practice. Moving on, just to wrap up with some conclusions. The first key takeaway from our own experience is having the required telemetry is key, right? You want to have both specific and sensitive use cases implemented. Do not shy away from those sensitive use cases if you can automate some of them, right? Consider which ones you can add code to. Implement BlueTeam code automation as part of your standard operating procedures. Very important. You might want to consider hiring some software devs as well, because I think we're at the stage where I think software developers could be very helpful. BlueTeam spiral of joy, of course. You want to use code-generated artifacts and use code to evolve your detections, tune your sensitive detections to arrive at that the joy stage where you have a much better base for you to be able to detect red team activity and ultimately the real-world attacks. So with that, I wanted to take a personal note. On the personal note here, in addition to being a passionate cybersecurity practitioner, I'm also a father of small girls, and they love coding. So they put together this little demo for you guys, the coding demo for their version of BlueTeam as code. So hopefully you enjoy this. All right, so hope you enjoyed this, and thank you all for attending. Really appreciate your feedback, and we look forward to your inputs. You can review some of our recommendations as to what we recommend that you do next, how you can apply, and then some helpful references. Thank you to all who contributed to this: Florian, Ismail, everybody who helped. Thank you all.
All right, very awesome stuff. So I didn't know if there were any questions that you had seen go by in the Slack that you wanted to address along the way, but if not, I do have a couple of my own. But first wanted to ask, was there anything that you had seen come in?
There is a number of them.
Yeah, I'm sure there's a lot of. I didn't know
great question
that you immediately locked your eyes on. We're like, oh, I need to address that. One of the things I wanted to I guess call out and both ask, right, is emphasize that this is some really cool stuff and forward-looking. Like how do we use Jupyter notebooks and Python code and all of that? And I love it. Every time I see Jupyter show up in an InfoSec presentation, I'm like, yes, right. I feel like the future is just one step closer every time we see that. Clearly, it's a super useful thing for this kind of analysis here. Is this something that you've used in any other context beyond just writing detections? Like, are you using Jupyter in general for really any other BlueTeam stuff yet?
Yes, we have other things that we use this for. Generally, it helps understand the landscape we're dealing with as BlueTeams, right? When you use code, you can query your environments, and you can see, hey, this particular environment has a lot of gaps, with particular event types, right? And so, you might want to, enhance, you might want to, implement additional GPO settings to enable those particular events, or you could configure particular cycles to collect additional telemetry so you could better detect red team activity. So all of that can fill the gaps for the analysts. And I think I'm excited about the fact that, we can now use the code-based or code-driven approaches for this.
Yeah, it's really a power tool for visualizing and harnessing a ton of data and trying to find the odd stuff in it, right? Which is kind of ideal for exactly what what you've shown us here. For those of us who might be looking at this and saying like, I get that Jupyter's cool, but I don't really know Python yet, but I have this data like in my sim. Is there any other packages or analysis methods or really any kind of stuff that you would recommend that people who might not have the coding skills yet could try in terms of getting this kind of work done?
Right. So what we would recommend is, looking at some of the examples that you have with Jupyter Notebooks. I think there's excellent work. We're not the first ones who came up with Jupyter Notebook driven detections, right? I think those additional things on top of it is, where, I think we, hopefully could add value. And so examples from the threat hunting playbooks, there's a lot of work in this area. You might want to familiarize yourself with those. Take some of the examples and take some of the code from our GitHub, right? You can use some of those examples in your environments, maybe modify them, see what works, what mappings you have for the events, maybe use additional visualization, just play with it. I think it's a great toy.
Yeah, absolutely. This is, I think, something that dovetails really well with what Justin was kind of saying in the beginning. Like you said, is like a lot of detections, and I love that you called out specifically the words, specific versus sensitive detections. I'm always talking about the same kind of thing. It's like some things are really easy to kind of write and they just work, and other stuff, it's like it's so down in the weeds, and you have to look at like every single log field, and you have to say, if this thing is here, but this thing is not over here, and this other thing is true, and it's this user on this system, and it's just like, I can't do it, right? And so you need like a tool that has the ability to cut it all down and show you where that commonality is. Justin and I were actually talking about a very, very similar problem on a webcast like 2 days ago. It's just, how do you wrangle data and find that nuance in there when you have a bunch of crazy false positives, and how do you make it as easy as possible? So I think what we've done here is a great addition to the efforts that are out there already to help us solve some of those really common problems that everyone's going to be facing on that sort of stuff. Also, I learned a new word, bathymetry. Didn't know that was a thing. Looked it up. The depth.
It was new to us too. It just sounds fancy. Yeah.
Yeah, it certainly does. It blew me away. And the super cool 3D miter attack thing. I don't know how you made that, but I love that too. I hadn't seen that before. So very awesome stuff.